hello and welcome everyone. So this video is going to be a walkthrough for the solution to this exam from Principles of Micro. What I'm going to do first is I'm going to show the exam, then I'm going to go through kind of deliberately each of the questions. So, it starts off with 22 multiple choice questions, then 3 shorter kind of free response type questions. All right, so, I don't know if you want to take a moment to kind of remind yourself of the exam if you took it, or if you want to practice from it for the future. Let me just show all the questions here. I don't know, it's probably easy enough for you to stop the video and then do these. And then I will do the walkthrough kind of immediately after. So the topic coverage is like comparative advantage, gains from trade, consumer surplus, producer surplus, labor market, drive demand, externalities, public goods, international trade. So those are kind of the main topics that we covered on the exam. Everything else we've done in micro to this point, like elasticity, taxes, price controls, supply and demand model, core principles of economics, all those things continue to be relevant, of course, and it's sort of the foundation for the exam. But in terms of this exam itself, those weren't the central topics. Central topics were the ones I mentioned first. All right, anyway, whatever. So here's the shorter or the longer form short answer type questions. All right. Okay, so that was the exam, kind of the blank version. Here's a solution. So like if you just want to check for yourself, here is the multiple choice. And then, I guess if you don't want my walkthrough, let me just real quick show the answer to the short answer. I guess if all you want to do is see the answer and no explanation, here it is. So, cool. All right. All right. And so now what I'll do is I'll kind of go through a little bit more deliberately. All right. So the first question. All of these will cause the labor supply curve to shift except. So the choices are a change in the wages of other occupations, change in non-wage benefits, change in expectations about future wealth, and a change in the wage rate. So if we're thinking about shifts, we want to think of our determinants of labor supply. We want to think of basically amongst these, what are something that's going to change the quantity of labor supplied at every single possible wage, right? So that's all of A, B, and C, but not D. A change in the wage rate, that's a change in the price. If there's a change in the price, we can only get a change in quantity supplied. When wages blank, if the substitution effect dominates, the quantity of labor supplied will blank. Well, so the substitution effect, this is where as wages rise, your time becomes, your leisure time becomes relatively less attractive, working becomes relatively more attractive. Right? And so then you'll spend more time working. So that's this right here. When wages increase, if the substitution effect dominates, the quantity of labor supplied will increase. Right? So this is our standard sort of upward sloping labor supply. If the income effect dominates, then you get the down, the backward bending, so if you drew that portion of the labor supply curve, it would look like a demand curve. It'd be downward sloping. Actually, as wages rose, you'd offer a smaller amount of hours to your employer at higher wages if the income effect dominated. All right, so if they spend all night writing computer programs, Lawrence can write 10 programs, Carrie Ann can write 5. If they spend all night making sunglasses, Lawrence can make 6 pairs, Carrie Ann can make 4. Given this information, supposing Lawrence and Carrie Ann have constant opportunity cost, we know that. Well, Lawrence has an absolute advantage in both, right? And we see this because this is giving how many they can produce. Absolute advantage is if you can produce more with the same resources or fewer resources to produce the same amount, right? So either way, whoever's more productive has the absolute advantage. That's Lawrence, because Lawrence produced more of both here. The harvesting of corn generates external costs in the form of methane emissions. In equilibrium, generates external costs. So we're looking at a negative externality situation. So if we have a negative externality situation, I wonder if I can, external costs. Good. I'm glad it highlighted that because that's kind of the key thing, kind of the key aspect to this question, although that's not what I was trying to do. So let's see. Sorry. So here I thought I was being super clever and I realize maybe not so much. All right, so here'd be our marginal private benefit. Here'd be our marginal private cost. I like how it straightens the line, right? I can't draw a good line here, but it's going to do it for me. So cool. If there's a negative externality, of course it does that. If there's a negative externality, there's an additional external cost, right? And so the idea is that this curve is going to be, so here would be like coincident with private costs, but now there's this additional external cost. It's going to raise costs overall because it's including the externality. This right here is going to be the marginal social cost curve. Sure enough, it's going to have a higher price, it's going to have a lower quantity than our market quantity. The market quantity would be this one right here and right here, because this is marginal private cost, marginal private benefit. So the decision maker paying attention only to their own interests would produce out here. That's overproduction relative to if we take into consideration this external effect, right? So I realize that's not labeled, but I walked through it carefully. Hopefully that's sufficient. If not, like I've got other videos where I do that like way more carefully. Hopefully at this point this is like relatively more closer to review. Anyway, so harvesting of corn generates external costs in the form of methane gas emissions. We did this. In equilibrium, the price of a bushel of corn will be less than the marginal social cost of the last bushel of corn sold. That's this picture, right? Here's the marginal social cost. It's inclusive of the externality. And what this is saying, actually, what this is, it says the price of a bushel of corn, that's going to be like what the market price is going to be. It's way down here, right? So it's lower than the socially efficient price. But what this is saying specifically is it's talking about a specific vertical distance. It's this distance from here to here, right? From here straight up to the curve. That's the size of the externality, right? So the distance between the two curves, right, is going to be the x. So this is the marginal private cost. This is the marginal social cost, which is going to be higher everywhere by the size of the externality. We can kind of get that a little bit better if we kind of look at where the vertical intercept would be. Let me just move it down here. I realize I'm moving the curve, but who cares? So this is that distance. This is the size of the externality right here, the distance between their vertical intercepts. And sure enough, that's going to be the same distance right here, right? Same distance everywhere. So anyway, what this is saying is this equilibrium price right here is going to be lower than the marginal social cost. That's what that's doing, right? And that happens exactly when we have a negative externality. Okay, cool. I will leave that there if I can scroll and that stays. Oh, it does. Cool. All right, so France must give up production of 100 ties to produce 50 additional dress shirts. The opportunity cost of producing 4 dress shirts is how many ties? Okay, so we want to get this in terms of dress shirts. So if we're producing 50 dress shirts, we can do that or 100 ties. So we could produce 2 dress shirts or 50 ties, or we could produce 4 dress shirts or 8 ties. Right? So that's why it's 8. The rational rule for society says the more of a good should be produced if the marginal social cost is greater than the marginal social benefit. If the marginal social cost is greater than the marginal social benefit, that's not good because now you've got like additional costs beyond what society is getting. As long as the social benefit exceeds the total social cost to everyone, well, we do have winners and losers, but that's not what the rational rule for society is saying. As long as its marginal social benefit is at least as large as the marginal social cost, yep, that's it. Remember, our rational rule is always going to be of the form marginal benefit is at least as big as marginal cost. Here, we're talking about for society, so it's marginal social benefit is at least as large as marginal social cost. And the last one, if the rational external benefit exceeds the rational internal. I don't know what a rational external benefit is, so it's not that. Okay, so if the country has a comparative advantage in producing wine, then the domestic equilibrium price of wine without trade in the country would be blank the world price, and the country would blank wine. If you have a comparative advantage, your domestic price is below the world price. So the domestic equilibrium price of wine without trade in the country would be below the world price or less than. Okay, so now we know we're looking at either A or C. And then what do you do if you have a comparative advantage? You export, right? So that's this, less than export. The accumulated knowledge and skills that make a worker more productive are known as human capital. Right? That's just definition. Which of the following is false regarding public goods? The fact the government should fund a public good doesn't mean the government should produce it. No, that's true. The fact the government provides it doesn't mean it's a public good. That's true as well. The fact something is a public good doesn't mean the government should. That the government is a public good doesn't mean the government should produce it. Okay, yeah. The fact that something is a public good doesn't mean the government should fund it. Yeah, so also true. The fact something is a public good doesn't mean it's non-rival. No, that's false, because by definition, A public good is non-rival and non-excludable. All right, so when your employees receive work assignments based on who has the lowest opportunity cost in performing each task, the basis for the work assignments is comparative advantage, right? Definition of comparative advantage is whoever has the lowest opportunity cost. Extrinsic motivation, the desire to do something for its external rewards, right? So these are two that are basically definitions. Through the income effect, a higher wage causes, it's going to be a decrease in the quantity of labor supplied, right? So we talked about this a little bit earlier. We said if the substitution effect, at the higher wage, you're going to increase your quantity of labor supplied. But through the income effect, a higher wage causes a decrease in the quantity of labor supplied. So that's going to be basically this picture. Yeah, that's a labor supply curve. Looks like a demand curve, but that's a labor supply curve when the income effect dominates, because then at higher wages, so this would be wage, this is quantity. I don't think I can draw this out. I think I don't know, let's try it. That's kind of cool. Maybe it'll make a nice W for me. Or maybe just leaves it there. Good. So there's wage. I think if I make a Q, it'll make it a nice Q. Or it'll just do that. Okay, cool. Sometimes it'll fix it. Now it just made this nice tail, so whatever. Okay, so the efficient quantity prevails in a market when the market yields the largest possible economic surplus. The efficient quantity, that's the socially efficient quantity. That's the one that's going to maximize total surplus, total economic surplus. That happens in our competitive equilibrium. So the efficient quantity yields the largest possible economic surplus. It's true by definition. Not the lowest average cost, not benefit equal to cost, and then not cost exceed benefit by the largest margin. That'd be the least efficient. Has benefit equal to cost? Well, so the marginal benefit equal to the marginal cost of the last unit provided. That's true, but this is just like general benefit equal to cost. No, that's not necessarily the case. All right, so a good has a free rider problem when someone can enjoy the benefits of the good without bearing the costs. That's true by definition. Free rider problem arises when you've got a non-excludable good. And then it becomes more of a problem in the public good, which is non-rival and non-excludable. Because of the fact that it's also non-rival, then people don't feel bad. So non-excludable means you can't limit who's able to consume the good. Non-rival means one person's use doesn't diminish how much in the universe remains for other people. And the free rider problem happens exactly when you've got a public good. All right, what happens in the labor market for public school teachers when a state government raises the minimum educational standards for certification for a public school teacher? Oh, that's going to decrease the labor supply. And if we decrease the labor supply, what's going to end up happening? So now it decides to fix my lines, whatever. So that would be a decrease in labor supply, higher wage, smaller quantity, right? Supply of teachers decreases, resulting in a higher wage and lower quantity of labor. All right. An example of a tariff, tax of 10% on the value of each Honda motorcycle imported from Japan. That'd be an example of a tariff. The other options, a limit on the total number of Honda motorcycles imported from Japan. That'd be like a quota. Regulations requiring automobiles meet certain specific emission guidelines. That'd be like a non-tariff or like a regulation sort of type of protectionism. The goal wouldn't necessarily even be protectionism, but it would maybe have that as an effect. Tax of $5,000 on each Honda motorcycle produced in the U.S. No, because it's not imported. It's produced in the U.S. All right, so the table provides data on the number of minutes it takes Bruno and Sasha to each change a tire and iron a dress shirt. Use the data to answer this question. So this is the minutes. This is their productivities. This is how long this is the time requirement to change a tire and the time requirement to change a dress shirt. If you got these reversed, probably you're thinking about these as if they're outputs, right? Okay, the answer here is B, 0.67 of a tire changed. Bruno's opportunity cost is 0.67, 2/3 of a tire changed, and Sasha's is 0.6, 60% of a tire changed, right? So when ironing a dress shirt. So here's how we think of this. Bruno irons a dress shirt. That's going to take 40 minutes. 40 minutes is 2/3 of the time necessary to change a tire, right? Takes 60 minutes to change a tire for Bruno. After 40 minutes, Bruno would have ironed a dress shirt, but would have, 20 minutes left on changing the tire. So ironing a dress shirt is going to take less time. However, those 40 minutes are going to be, 40 divided by 60, or 2/3 the time necessary to change a tire. And then for Sasha, it's going to be 45 divided by 75. Yeah, that's 0.6. Okay, so suppose you want to show the minimum wage has a small impact on employment. It'll help your argument if you can show that in the market for unskilled labor, demand is inelastic. There's two ways to think about this. The first one is we can say, well, if demand's pretty unresponsive, then when the minimum wage raises the price of labor, if demand's pretty unresponsive, by the law of demand, we know the quantity demanded is going to fall, but if it's unresponsive, if it's inelastic, it won't fall by much. And what you can do basically is you can draw a collection of demand curves and supply curves to model each of these. I'm just going to draw this one. So let me draw the demand curve. Here's kind of like a relatively elastic supply curve. And now I'm going to draw in a minimum wage, right? Okay, so let's imagine the horizontal line's minimum wage, the vertical is wage, horizontal is quantity. This kind of flat upward sloping curve is supply. I don't know, maybe it'll let me put an S there. Hey, it does. And then this is going to be demand. I guess I was getting super greedy with my ability to draw letters here with this draw tool. Well, that's so annoying. Okay, well, that's a D, so I don't know if you could tell. And then here's the minimum wage. That's what that is. Whatever. So the point is, look, here's our demand curve. Let me make this even more inelastic. Here's the demand curve. Where would be the market equilibrium? Right here. There's going to be where the quantity demanded is with the minimum wage. And if you just draw this out for yourself, because my picture's terrible. But the idea is like the quantity of labor, the quantity of jobs like offered and filled, that's employment, right? So here's like the equilibrium employment. It's like right under that where they cross. And then when the minimum wage is imposed, the new employment is like just a hair lower, right? So the idea is like, because demand is so inelastic, this minimum wage, yeah, it rose the price kind of a lot, but the quantity demanded of labor didn't really decrease by much. Okay, so suppose medical research provides evidence that eating cherries provides far greater health benefits than previously thought. The resulting increase in demand for cherries, well, we have to kind of think about what this is going to do. The first thing is, well, as soon as I see like, suppose medical research provides evidence eating cherries provides greater health benefits, this is like one of our quintessential demand shifters, right? A health report says that oatmeal is going to be more useful than we thought before. Good, that's going to be an increase in taste and preferences for oatmeal. Well, in this case, health report for cherries, so there's going to be an increase in demand for cherries. Well, how is that useful here? So the resulting increase in demand for cherries, what's that going to do? As we start reading these answers, it's about like marginal product, marginal revenue product, supply of cherry pickers. So now we're thinking about like, well, we want to obtain cherries. We need cherry pickers to pick cherries. So I don't know if we're talking about people or if we're talking about like those like truck basket things or like ladder baskets to pick cherries. Either way, it's not going to matter. The first one says increases the marginal product of cherry pickers. No, the increase in demands is not going to be able to change the marginal product. Remember what marginal product is. Marginal product is how much additional output do we get from using one more unit of the input, right? So this would be like, how much additional cherries do we get from hiring one more or employing one more cherry picker, right? So you get one more of those cherry basket things. How many additional cherries you're able to get? That's marginal product. That doesn't have anything to do with demand for cherries, right? Okay, but what about this? Increases the marginal revenue product of cherry pickers for any given number of cherry pickers? Sure, yeah, it can increase the marginal revenue product. Why? Well, remember marginal revenue product. We said marginal revenue product is, remember in class I said PMPL. So PMPL, right? And I said, you're not really responsible for like PMPL and like that whole thing, but it's useful actually to spend some time thinking about it because this is marginal revenue product. And so the book's definition is what? Marginal revenue product. Marginal revenue product is equal to output price times marginal product, or PMPL. It's the same thing. See if I can expand this. Cool. So marginal revenue product is output price times marginal product, or just PMPL. P is the output price, right? We get a rightward shift in the demand for cherries. That's going to increase the price of cherries. That's this P right here. And then the marginal product of cherry pickers themselves, that's MP. And then L means like marginal product of labor. I don't know. This could be MPK, so like marginal product of capital, if we believe that these cherry pickers are referring to those like basket things. It doesn't matter, whatever. So the marginal product is how much additional output are we going to get when we hire one more cherry picker or employ one more unit of cherry picker capital or whatever. That's gonna get multiplied by the output good price, and this jointly is the marginal revenue product, right? This is like how much additional output do we get, how many additional cherries do we get from hiring one more cherry picker, and then what's the value of that? To understand what the value is, we have to multiply it by the output price. All right, so that's all that is. Increases the supply of cherry pickers. Now, we have no reason to think this is going to have any impact on supply. All of the above are correct? Nope. Only A and B are correct? Nope. The best answer here is B. Right, marginal revenue product. It's definitely not A. We have no reason to think it should be C, and then that disqualifies D and E. Okay, so New Zealand has decided to end its policy of not trading with the rest of the world. When it ends its trade restrictions, it discovers that it's importing incense, exporting steel, neither importing nor exporting rugs. We can conclude that, right? So this is going to talk about like all these markets. Well, the first thing is I'm just going to stare at rugs. It's neither importing or exporting rugs, so it's not going to have any impact on the market for rugs. So consumer of the market for rugs are unaffected. Where's this one right here? Always helps consumers now. Both consumers and producers of rugs are unaffected, and then both consumers and producers of rugs are unaffected. Okay, that only helped us a little bit, and then we have to read this one. Domestic producers of incense and steel are worse off. Domestic consumers of incense and steel are better off because trade always harms producers and always helps consumers. No, that's ridiculous. All right, so when it ends trade restrictions, discovers it's importing incense. If it's importing incense, the winners are going to be domestic consumers. The losers are domestic producers. So let me look at incense. Domestic producers are, well, I just read that one. Domestic producers of incense are worse off. Yep, that works. Domestic consumers of incense are better off. Yep, that works. What about down here? Producers are better off. Nope, it's not C, because the producers are not better off. Domestic producers of incense are worse off. Yep, domestic consumers of incense are better off. Yep, that's right. Okay, now let's look at steel. Discovers that it's exporting steel. If it's exporting steel, that's good for domestic producers, bad for domestic consumers, because you're going to bypass the domestic consumers and sell to foreign consumers. All right, so we want producers of steel are worse off. Nope, can't be this one. Can't be A, because producers of steel are actually going to be better off. Oh, then it has to be D. Yep. And then let's just verify. Domestic producers of steel are better off. Yes. Domestic consumers of steel are worse off. Yes. Yep, that's right. Okay, cool. Which of the following must be true of negative externalities? Oh, we saw that picture from just a second ago, right? In the case of a negative externality, we're going to have marginal social cost higher than marginal private cost, and we're going to have market price below socially efficient price. So marginal social cost exceeds marginal private cost. Market price is less than socially efficient price. Yep, so it's this one. Marginal social cost, let me just read the other ones. A, marginal social cost exceeds marginal private cost. Yeah. Marginal market price exceeds the socially efficient price. No, because the socially efficient price is going to be the one where the higher marginal social cost crosses marginal private benefit. The market price is the one that's actually going to happen, and that's where private benefit crosses private cost. Marginal social cost is less than the marginal private cost? No. Marginal social cost is equal to marginal external cost. Well, the marginal social cost is going to be the marginal external cost plus the marginal private cost. So it's not D. Marginal social cost is equal to the marginal external cost, and the market price is less than the socially efficient. No, it's not equal to the marginal external cost, right? So D and E are missing the fact that marginal social cost is the externality plus the private cost. The world price of a pound of apples is lower than the equilibrium price in the U.S. would be without trade. Lower today than it would be in the U.S. without trade? Let's see. Without trade, the price is going to be higher, so the U.S. lacks a comparative advantage in apples. Compared to the situation without trade, what happens to the consequences of free trade? So if the U.S. lacks comparative advantage in apples, the U.S. is going to import apples. So domestic price is lower, prevailing price is lower. Consumer surplus is higher when importing apples, and then total economic surplus is higher, so it's this one. Americans export apples, nope. Americans import apples, okay. Consumer surplus is higher, yes, but total economic surplus is lower, no. Not with free trade. Domestic price of apples is the same. That'd be so weird. But firms export apples at the world price? No. If domestic price of apples was this, you wouldn't. Why would you export? There'd be no incentive to have those units leave the economy, especially if you're paying attention to trade costs. Domestic price of apples is higher. Consumer surplus is lower. Domestic equilibrium surplus is higher. This would be the import. This would be the this would be the export situation. We'd be exporting in A, we're importing in E, but we're going to import because the U.S. lacks a comparative advantage in apples. Okay, so now we've got these two dogs, Howard and Dudley. They collaborate to produce mayhem. The only two activities are digging holes and destroying socks. Both Howard and Dudley work 24 hours a day. Each hole takes Howard 4 hours to dig. Each sock takes 1.5 hours to destroy. Each hole takes Dudley 3 hours to dig. A sock takes him 6 hours to destroy. When working on their own without the possibility of specialization and trade, Howard digs 4 holes, and Dudley also digs 4 holes. Each uses the rest of the day to destroy as many socks as possible. So firstly, what's the max amount of holes that Howard could dig? What's the max amount of socks destroyed? What's the max amount of holes Dudley digs, socks destroyed? So we're interested in what's the most that they could do, right? So we want to disregard this part when working on their own without the possibility of specialization and trade. We want to focus on what could they most, if they put all their time to it, what's the maximum amount they could possibly get, right? So in 24 hours, Howard digs 6 holes or destroys 18 socks. Howard's opportunity cost of 1 hole is 3 socks, right? 6 holes or 18 socks. Therefore, you could divide through by 6. 6 over 6 is 1. 18 over 6 is 3, so 1 or 3. Howard's opportunity cost of 1 sock is 1/3 hole. What's the maximum amount of holes that Dudley digs? Socks destroyed. Well, in 24 hours, Dudley digs 8 holes or destroys 4 socks, right? So 1 hole or 1/2 sock. Let's just divide through by 8. 8 divided by 8 is 1 hole. 4 divided by 8 is 1/2 sock, right? So opportunity cost of 1 hole is 1/2 sock, or 1 sock is 2 holes. Okay, so let's look for the smallest number amongst everything we see here. It's this 1/3. So let's see. Howard's going to have the lowest opportunity cost associated with eating socks, right? And so has a comparative advantage in socks. Therefore, Dudley has the comparative advantage in holes. And sure enough, Dudley's opportunity cost of 1 hole is 1/2 sock, but Howard's is 3 socks, right? So who has a comparative advantage in digging? Dudley. In eating or destroying socks, Howard. If they're allowed to specialize in trade and collectively end up with the same number of holes dug as before, how many more socks would they be able to destroy? Well, the number of holes that they'd have is 8, 4 from each, right? They each make 4 holes. This cost Howard 12 socks, so Howard can make 18 minus 12, which is 6 socks. Those 4 holes cost Dudley 2 socks. Dudley can make 4 minus 2, or 2 socks. All total, we get 8 holes and 8 socks. That's 10 more socks available via specialization, right, compared to the 18. Right, so they get 18, right, when specializing. They'd get 8 when working alone, so 10 more available through specialization. Here's Howard. Here's Dudley. All right. So the United States, specifically California, is a major producer of Hass avocados. Suppose U.S. actually holds a comparative advantage and therefore exports avocados. Let's see. So we want to draw the domestic demand, domestic supply, world price, indicate the domestic quantity demanded, domestic quantity supplied at the world price, as well as the quantity of exports. Right. So basically just wanted to have here's domestic demand, here's domestic supply. Got to draw the world price above the domestic equilibrium price because we're going to export. Therefore, we have a comparative advantage. And then you want to label domestic quantity demanded at the world price, domestic quantity supplied at the world price. Domestic quantity supplied is greater than domestic quantity demanded, so that's a surplus, but it's a specific type of surplus because this is going to then bypass, you're going to send these into the other economy as exports. Interestingly, what happened here beyond the equilibrium quantity is this is like new production that's produced and sold abroad. This is production that wouldn't happen, these units right here. This is production that wouldn't happen in the domestic economy alone or in the absence of free trade, right? It's only at this higher price that these sellers are willing to make those units. Now, these units right here, this is redirected. These are units that originally would have been sold to these U.S. consumers. However, these U.S. consumers, here's their marginal benefit, but here's the marginal benefit to foreign consumers. These foreign consumers outcompete these domestic consumers, and so we bypass the domestic consumers and instead sell them to these foreign consumers at this price. All right, so that's what happens. Who gains and who loses? Well, if you just follow what I was developing just then, U.S. producers are winners, foreign consumers are winners. U.S. consumers are losers, foreign producers are losers. Had to talk about both, right? Both winners and losers in both countries was what I asked for here. So it's actually like, 1 point for each of the places, and then 1 point for each of the producers and consumers. All right, so company Econ produces paper as a byproduct, emits a terrible stink, affects drivers driving past the city on Highway 41. Model the situation, use supply and demand diagram, clearly indicate everything. All right, so this is the negative externality situation. Here is our marginal private benefit or our demand curve. Here's our marginal private cost, right? And then the marginal social cost additionally includes the externality, right? So there's going to be this additional cost. It's going to be the odor, right? The size of the externality is going to be the distance from here up to the marginal social cost curve, right? The distance between the marginal social cost and marginal private cost is going to be the size of the externality. So this is what we were looking for. Wanted quantity, the socially efficient quantity, the market quantity, market price, socially efficient price, marginal social cost, marginal private cost, and then demand or marginal private benefit, right? Will the Coase theorem work here? No, the Coase theorem says that if bargaining is costless, then it's not going to matter and if bargaining is costless and property rights are enforced, then it's not going to matter to whom the original property rights are assigned. We expect the decision makers are going to come to the efficient solution. That can't happen here because think about it. We've got like a lot of different drivers going past on this interstate highway. We can't get every relevant stakeholder together. So negotiation costs are pretty high. The reason why it doesn't apply is it's not costless to negotiate in this one. So 2 points for saying no, 2 points for using good alternative or explanation, right? All right, cool. So let me go ahead and conclude here. Hope you enjoyed the video. Hope you enjoyed the test, and I will see you next time.